All right, so if you guys can see, we have two different scatter plots here. And the whole purpose of the scatter plots is to make a prediction. And so we want to figure out, we understand that scatter plots aren't going to have a perfect linear relationship, but if they are linear, we can write an equation for the pattern. So you guys have done lines of best fit since middle school. You're gonna say, I tutor middle school kids all the time, but whenever you're doing a line of best fit, don't you tend to draw it like through the middle? You want to go through as many points as you can and have an equal amount of points on each side. So on these, since these both had negative correlations, you would have had a negative line going through it. Now on this first example here, that's a positive correlation, right? So we can draw a positive line. Now we tend to, when we go to write these, we want to create a line that goes through as many points with keeping it on the same side. So I will tell you guys, for your first attempt, try to always connect the first point to the last point and see what that looks like. And if it doesn't look well, then we can adjust it. Now on Canvas, do you guys have the ability to actually like draw in a line instead of hand draw it? If you actually like put a line in and then adjust it to make it look, I'm gonna say, my Scouts kids make graphs all the time, so I think you might actually be able to do that. But you can either hand draw a line, and I'm gonna draw it from the last point to the first point. What do you guys think? I'm gonna say it's pretty close. I do believe that that fifth point, like that 200 or 350, I think I actually dipped my line down, so that technically, let's make it look a little better. This point right here, I kind of made the line go a little crooked. All right, that's as good as it's going to get. Now, do you think that it would be a big deal if I connected it to this second point on, or the point on the left at the top? Just say, we are estimating. Everyone's trend lines are going to be slightly different. So when you're doing these by hand, you're going to get different answers. Now, tomorrow we're actually going to do it with technology. But if we look at this, we have the list of ordered pairs. So whenever you draw a line, if you want to write an equation, you have to pick 2 points that are on the line. So what is that smallest point? Just by looking at the table here, what is that smallest point in the bottom left-hand corner that we have on the line? You would say, out of this list of ordered pairs, which one do you think is this small one at the bottom left? All right, it's 3,200. And then what's this last point here? All right, so we are actually going to use these points and do rise over run. So this one is going uphill. So we have to find the slope. And you guys all know the slope, and you maybe have never seen this symbol before. A triangle actually means change. So this actually means change in y over change in x. So please write that down. All right, so if we talk about change in y, the smaller y coordinate is 200, and then it goes up to 1,800. So over this graph, how much did it change on the y? If it goes from 200 to 1,800. Yeah, the change is 1,600, and it's an increase because it's going up. So we could do the slope formula, but I would rather just look at it this way because it is a little faster. All right, now for the second point, the change in x. The smallest x coordinate was 30. The biggest one was 900. So that's an increase, right? We're going from 30 to 900. How much does that increase by? 870. guys will need a calculator, and just to make it faster, just use your phone. All right, let's take 1,600 divided by 870. We can use decimals when we're estimating. I'll say let's round to the nearest hundred. So two places after the decimal. If you divide that, Donovan, what do you get?
1.84.
You guys agree with that? 1.84? Alright, and then the second part, we said we like our equations. This is the easiest form for a line that we have. So our slope is going to go in here. Now, do you guys remember what a b value is on a graph? Say, go back to algebra 1. Whenever we say y equals mx plus b, what is b?
Slope, right?
M is the slope.
The y.
It's something to do with the y. It's the y-intercept. So it's where the line crosses the y-axis. So if you guys look here, where does it appear that this is crossing the y-axis? Around 0. So guess what? We can just write y equals 1.84x. Now, it appears that it's 0. Now, sometimes it's a number. And we're just estimating today, so that's totally fine. So it appears that it's crossing around 0. Now, tomorrow, we're going to plug this in on Desmos, and we're going to get a more accurate answer. But for today, we just want to estimate. The change in y, we find a point on the line where it's smaller, where it's bigger, we're going to find out the change. Find the change in x, and then if we divide those, we get the slope. So then we plug that in, and then we might want to write, this is the y-intercept, so we want to look where it's on the y-axis. I say one thing I love about algebra 2 is we don't have to have perfect answers. Say, a lot of it is dealing with estimating. Alright, do you guys have any questions on that first one? Alright, so we're going to go through these. Honestly, we're going to go through as many of them as we can. If we don't finish all of them, that's totally fine. We can do more tomorrow, and then we can use Desmos with them as well. So on that second one, let's go ahead and draw in our trend line. Alright, so on this one, if you connect your first point to your last point, does it look balanced? Does it go through a lot of points and has an equal amount of points on each side? What do you guys think? I say, you guys can be honest. Do you guys think that looks balanced? Not really. So on this one, whenever we put that line in, we now have 1, 2, 3, 4 points above it and only 1 below. So we actually need to adjust this a little bit. That's why I like using this instead of an actual pencil because it's much easier to erase. We need to shift it up a little bit. Let's see. I'm actually going to try connecting this point and this point and seeing what that does. Does that look a little bit more balanced? You'll say, it's better than what it was. So now we have 2 points above, 2 points below, and then like 2 points that kind of hover on the line. That's a lot better. So we need to figure out those 2 points that we connected. Where are they at in this table? So this first point that I circled, it's a little bit below, or it's almost to 4,000. So which one do you think that is? You guys, they're in order. Do you guys think that that's the first point I circled right here? And then the second point, it's the last point before I hit 8,000. So do you guys think that's 7,000.4? So 5,000, 6,000, 7,000.4. Now these are the same. It really doesn't matter which one you circle. So whenever we make the trend line, I just recommend that you make sure that it goes through at least 2 points, so that way you can do your slope. So when you draw your line in, draw it in, and then figure out 2 points that are exactly on the line. We wouldn't want to choose this point at the far right that's right above it, because it's not exactly on it. We want to be as accurate as we can. So if we take a look at this, we got to do change in y first. So the y coordinates, it goes from 0.2 to 0.4. So what's my change in y? How much, if it goes from 0.2 to 0.4? Yep, that's an increase by 0.2. All right, now for change in x. It goes from 3,000 to 7,000. So what's our change? So we're just figuring out how much it is. Now, if it were a decrease from the first point to the second point, what kind of sign would we add with that? Yeah, we would add a negative if it were a decrease. But in this case, they were both increases. So you guys have your calculators. Let's divide. What is 0.2 divided by 4,000? 0.2 divided by 4,000. You guys get this? On this one, we have something that's so close to 0 because, first of all, that y, it's counting by 0.2s. Like, it's very small. So it's almost 0 because 0 would be a flat line. 0 would mean no change at all. If you're only increasing by 0.2, it's just barely going above. So we have that. Now, if you guys appear for your y-intercept, where does it appear that it's crossing the y-axis? Around 0.1. It's in between 0 and 0.2. And so to write our equation, we would just write y equals 0.00005x plus 0.1. So our m goes in. So just going back to that slope-intercept form that you guys probably love so much in Algebra 1. So that's actually what I'm doing in Algebra 1 right now. Writing equations in slope-intercept form. All right, what do you guys think? So you guys are really quiet, but you say, I just personally, on estimation, I don't like to use the slope formula just because I feel like it's unnecessary work. So I want to do at least one more on the recording. And let me see. Do I need to go back? I can. Does anyone need more time? All right, so let's see. All right, I actually want to skip 3. Let's look at 4. So this one, we'll come back to tomorrow. All right, so let's take a look at number 4. All right, this one, is it a positive or a negative correlation? All right, and does it appear to be linear? So they're all linear today. So if they're linear, we can draw a trend line or a line of best fit. So let's just see what it looks like when you connect the first and the last point. So if you guys want to use the line feature, you can, or you can use your hand, just draw it in. That's not too bad, is it? stick with it. Say, we have almost as many points on top as on bottom, and they're all pretty much touching the line except one, so I think we're good. So we have our first point. The first point, and that's one thing I did put the points in order to make it a little bit easier for you guys to identify the coordinates. So the first point here that we started with our line is this coordinate here. And then the second point down here is this last point. So let's figure out change in y over change in x. Alright, so for change in y, alright, the y coordinate for the first point is 9,000. But then it goes to 2,000. Is that an increase or a decrease? Decrease by 7,000. So for the decrease, we include a negative, and it's decreasing by 7,000. So then we got our fraction, and then we're going to do a change in x. All right, so we start out at 600, and we go up to 8,700. So 6,000 or 600 to 700 would be 100 plus 1,000, so 8,100, and it's an increase, so that's a positive. So when we divide this, a negative divided by a positive will give us a negative slope. What did I do with that calculator? I must have walked it back to my desk. All right, so let's get our calculators out and let's find our slope. All right, 7,000 divided by 8,100. All right, so this is, I'm going to write it up here. All right, my slope is a negative because negative divided by a positive. Did you guys get 0.86? You should have had like 0.8641975, but we can round it to the nearest hundred. Now, where do you think, if we were to extend this line, so first of all, it's counting by thousands. They're only marking those, so this would be 9,000, this would be, so if we wanted to extend this graph, where does it appear that it would cross? Around 10,000. So our B value that we're going to use is close to 10,000, where it hits the y-axis. So we can write our equation. So we are going to plug in our values for M and B. So we'll go with negative 0.86x plus 10,000. Right, any questions?